Now that we've done some work to find some power series for functions on our own, I want to take advantage of some properties or operations that we can do with power series. So just like we got lots of properties for limits or derivatives or integrals, we're going to get some properties here for what we can do with multiple power series. So if you've got a power series for a function f and a different power series for a function g, let's say you wanted to, instead of just doing f of x, plug in some number times x. So maybe find 2x plugged in. Then all you need to do is take your power series and plug in kx. If you simplify that, this is what you get, k to the n, x to the n. Okay, similarly, if instead of just plugging in x, maybe you wanted to plug in x squared, then all you would need to do is plug in x squared into your power series, which would cause you to multiply those exponents together. Okay, the last thing we can do, you can also add or subtract power series from one another. So if you've got two power series and you want to find the power series for the sum of those functions, add together the power series. Same thing for the difference, just subtract them. Now, it is worth noting that when we do these operations, that can change the interval of convergence. But kind of a nice shortcut for us is if we're doing this adding or subtracting operation, the way it's going to change the interval of convergence is by finding what's called the intersection of the original intervals of convergence. And that's like kind of the overlap between those two intervals. So let's try out an example of this just to make sure we understand how the concept works. We're going to find a power series for the function 3x minus 1 over x squared minus 1. And I'm giving you a hint, which is actually just the partial fraction decomposition of that function. So I've done that step for you. Could you do it yourself? Sure, but that's not what we're focusing on in this problem. Okay, so we've got our partial fraction decomposition. I bet I could find power series for each of those guys. They each already look almost like a over 1 minus r. So let's start with the first one, 2 over x plus 1. If I was going to write that as a over 1 minus r, I would need to write it as 2 over 1 minus negative x. So I've got a equals 2, r equals negative x. Okay, so this first guy is going to be the sum of a r to the n, so that's 2 times negative x to the n. Alright, now let's work on the second one. 1 over x minus 1. We've actually seen this one before. Okay, so it's not quite in the right form. What I would need to do is swap around this denominator by multiplying the whole thing by negative 1. And now it's in the right form. Okay, so I just multiplied the top and the bottom by negative 1. So for this one, we've got a equals negative 1, r equals x. So my series is negative 1 times x to the n. So now, if I want to go ahead and add these guys together, let's try that out. So I should have the first series, which is 2 times negative x to the n, and the second series, which is negative x to the n. And I can combine them now into one series, just by adding those terms together. Notice, these guys are a little bit different. Okay, this one isn't negative x to the n. That would be different. It's just a negative sign. So one way I can make this a little simpler is to bring that negative sign out front. Okay, that way I'm not tempted to try to combine those guys. Negative x to the n is very different from negative x to the n. Okay, so my combined power series when I subtract these guys is 2 times negative x to the n minus x to the n. Great, so I just found a power series for those guys. Let's see if I could factor this out maybe even a little bit more. So I could write this as 2 times negative 1 to the n times x to the n minus x to the n. And if I factor out the x to the n terms, this is yet another way I could write it. Typically when we write a power series, it's a little more clear to write it so that we can have that x minus c to the n term by itself. That way the stuff out front is just going to be the coefficient of that. So if I wanted to work out the first few terms of this, I could plug in n equals 0, and then n equals 1, and n equals 2. But just to show you what it ends up looking like, we're just going to bounce back and forth between 1 and negative 3 for our coefficients. So kind of an interesting power series here. Okay, so there I've got it written with sigma notation. Here I've got it written without sigma notation. Sometimes I'll ask for each of those notations, just depends on the problem. Now let's figure out the interval of convergence for this guy. So one of the things I told you when I was breaking down our properties or operations with power series is that if you add or subtract power series, The interval of convergence for that final power series is just going to be the overlap of the two original intervals of convergence. So if we start with this first guy here, let's see, this one looks like the r is negative x. So put that in absolute value and set it less to 1. So yeah, that's just going to be all the numbers from -1 to 1. Okay, so let's do that in red. Okay, so for my second one, this guy here, negative of x to the n. Well, once again, my r, well actually different this time, my r is just going to be x. So I want to set absolute value of x less than 1. So this time, my interval of convergence is all the stuff from -1 to 1 again. So then my question for my final power series is, what is the overlap of these two guys? Right, so imagine squishing those two number lines on top of each other and just trying to see what's shaded in both red and blue. Well, it turns out the overlap is everything. So that's not a very interesting result this time. So the overlap of those two intervals is still all the stuff from -1 to 1, not including the endpoints. Sometimes those overlaps do get a little more interesting. Like maybe one of them could go from -1 to 1 and the other could go from 0 to 2. The overlap would just be the stuff from 0 to 1. So it's really just seeing where they overlap, and the mathy term for that is intersection. Okay, so the interval of convergence for this guy is all the numbers from -1 to 1, not including the endpoints.